let's go ahead and get started. Good morning, everyone. We have the test on Wednesday, so today I'm going to go through some of the questions on your practice test that I sent out, and then tomorrow we're going to take a practice test in class, so that way you can practice a little bit more on your time management as well as what you need to practice at home. I am available tomorrow before school for tutoring, 7:30 in the morning. I was available this morning as well. Good morning. And then I'm available today during lunch, and I'm available tomorrow during lunch for your test. Later on today, I'll give you a little worksheet to fill out for your retake exam, so that way you can sign up for it. And then I'll recollect those today as well. So let's go ahead and get started. So this is the Are You Ready? First question we have is 3 plus 8i plus 7 minus 2. Please be careful on what it's asking you. Do not multiply when it's not asking you to multiply. This is asking for something that is addition. This is asking for something that is subtraction. If you have a minus in front of a binomial, then you have to distribute that minus. We don't have any of that. So this is just saying 3 plus 8i plus 7 minus 2. So we have to combine like terms. 3 has no letter. 7 has no letter. 2 has no letter. The only one with the letter is your 8i. Now we do want to write this in the correct format. So I'm going to add 3 and 7, subtract 2. So we get 8. Correct format is we want the real followed by the imaginary. Okay, so the imaginary comes after. Now, when you do have a binomial, it would look something like this. A negative 4 minus 6i minus an 8 minus I. Here's your binomial that's attached to a subtraction. Again, don't multiply when it's not asking you to multiply. This is asking for a subtraction. So we're going to distribute both 8 and negative I gets its symbol switched. So if you see a positive, it becomes a negative. If you see a negative, it becomes a positive. So we have negative 4 minus 6i. 8 is positive, so it becomes negative. I is negative, so it becomes positive. And now we're doing exactly what we did up top. Number with number, letters with letters. So we have a negative 4 without a letter. We have a negative 8 without a letter. We have a 6 with a letter, negative. And we have a positive 1i. So we're going to combine those. Real is before imaginary, so I have negative 4 minus 8, which gives us a negative 12. Negative 6 plus 1, that gives us a negative 5. I, imaginary. Yes, sir. It would be in correct format, yes. Yeah.
What would this format be called?
This is called a complex number. So this is complex number format, so we want to make sure to put the real before we see the imaginary. Any questions on the first two on adding and subtracting? Adding, subtracting. Any questions? Good? Okay, let's move on to multiplication. So we have 2 plus 7i squared. You're going to see one of these with the bubble squared. Anytime you see parentheses, squared, cubed, fourth, whatever the exponent is, write it out that many times. It really does help your brain not play tricks on you. Right now, looking at 2 plus 7i squared could be playing tricks on you. Don't let that happen. Rewrite it twice. Why are we rewriting it twice? Because the exponent is 2. Here's your equals. So we got 2 plus 7i times 2 plus 7i. Once you rewrite it twice, then your brain's like, oh, well, maybe I should distribute. Maybe I should use the box method. It's your choice if you want to distribute or box method. But because you now see 2 parentheses, you know that we are multiplying. Be careful. Subtraction, multiplication. So 2 different methods. I'm going to choose to use a box method. If you wish to distribute, that's fine. We got 2 plus 7i. We got 2 plus 7i. If you remember your patterns from our polynomial unit, you can use your patterns. If you don't know what I'm talking about, that's fine. Just multiply out. We got 4. We got positive 14i. We got positive 14i. 7 times 7 is 49. I times I is I squared. But we know that I squared is what, beautiful people? Good. Negative 1. So we get negative 49. I'm going to circle negative 49 because a lot of things happen in that little box. I don't want to accidentally take the wrong number. So we have 4 plus 14i plus 14i minus 49. Again, you want to combine the real with the real and imaginary with the imaginary. So 4 is without a letter. Negative 49 is without a letter. 14i positive, 14i positive. So we're going to combine like terms. So 4 minus 49, that is negative 45. 14 plus 14 is 28i. On your Are You Ready? Question number 4 is pretty much exactly the same thing, just with different numbers. So I'm going to skip that one. I'm going to move on to division on question number 5. Yes, ma'am. Say that a little louder. I didn't hear you. I'm sorry.
Are these all individual problems or part of the same problem?
What do you mean? Like the directions? The directions?
Are those numbering different columns? Or
Correct.
all-
Yeah, so this is question number 1. This is question number 2. This is question number 3. And now we're moving on to question number 5. But the directions for all of these will be one set of directions. It will only say simplify. Does anyone need more time on this? Okay, let's move on. Question number 5 is 4 minus 8i divided by negative 3 plus 10i. So this is our division problem. Even though we're not technically dividing, we are going to be multiplying by the conjugate. Now, a conjugate is where you take that denominator and you're going to multiply by its conjugate. So this denominator is what you're going to be multiplying top and bottom with a slight change. So on top, we're just copying everything the same. So negative 3, 10i, negative 3, 10i. And that small little change is going to be that symbol in the middle. Yes, sir? Like this? Uh-huh. And that small little change, what we're doing is this middle symbol and only the middle symbol. Notice I did not mess with the negative 3. It was a negative 3. It stayed a negative 3. What we're messing with is the middle symbol. It was a positive. We're creating a negative. Now, it is your choice, again, how you would like to proceed. I highly encourage you to do a T-chart here, separating out your numerator and your denominator. That way you don't accidentally multiply, add the wrong things together. In our numerator, we got a binomial of 4 minus 8i times negative 3 minus 10i. In the denominator, we have negative 3 plus 10i. We got negative 3 minus 10i. In the denominator, you should have conjugates. That means that these two are exactly the same except the middle symbol. If you don't have conjugates, that will end up giving you an I in your denominator, which is a big no-no. We cannot have any I's or radicals in the denominator. That's why we're doing this. All right, I did the box method last time. I'm going to choose to distribute here, and then I'm going to choose to do the pattern for our denominator. So I'm going to distribute 4 times negative 3, 4 times negative 10i, negative 8i times negative 3, negative 8i times negative 10i. If you wish to do a box method, you can do a box method. We get negative 12, negative 40i, positive 24i, positive 80. I times I is I squared, but we know that I squared is equal to negative 1, thank you. So we get negative 80 here. So I'm going to write this out so that way we can combine like terms. If you wish to combine like terms now, you can. I like to write it out so it's easier for me to see what's happening with my numbers. I have a negative 12 minus 40i plus 24i minus 80. Once again, number with number, letter with letter. So we got a real number of negative 12, a real number of negative 80. We also have imaginary stuff like negative 40i and 24i. Combining like terms, we have a negative 12 minus 80. That gives us a negative 92. Negative 40 plus 24 for our i's is a negative 16i. Thank you. For our numerator. Again, this is not the answer, so please don't think this is the answer. Okay, not the answer. This is just what's in the top. Now for our denominator, you have an option to make. You can either choose to do the box method, distribute, or you can choose your binomial pattern. It is up to you. I'm going to choose to do the box method. Negative 3 plus 10i, negative 3 minus 10i. Negative, negative, positive. 3 times 3 is a positive 9. We get a negative 30i here, positive 30i here. 10 times 10 is 100 with a negative. I times I is I squared. You guys already told me that that I squared is negative 1, which gives us a positive 100. Again, combine the real, combine the imaginary. And for this side, for the denominator side, this is why we're doing this. This is kind of like the whole purpose. It cannot end up with an I. Can't have I in the denominator. So you'll notice that when we simplify, our i's end up disappearing. And we end up with 109. Again, that 109 is not our answer. This is just the denominator. And I'm going to write out our answer here in an answer box. And we have negative 92 minus 16i divided by 109. If you can simplify, simplify. If you can't, that's fine. Yes, ma'am. So the question number 5 is one problem. We are dividing a binomial by a binomial by multiplying by the conjugate. We have a numerator that happens on top. We have a denominator that happens on the bottom. All of this is one question. You're welcome. I see pencils, so I'll give you a few moments to finish writing. Does anyone still need more time? Okay, that's fine. Go ahead. All right, let's go and move on. We're going to move on to question number 7, skipping number 6. Number 6 is going to be similar like number 5. And this one is asking you to solve each equation by taking the square root. For question number 7, we have x squared plus 6 is equal to negative 14. And we are solving by taking the square root. Step number 1, when you're taking a square root or solving by taking a square root, we want to make sure that x squared is by itself and nothing is attached to it. Undo addition subtraction first, then divide if you need to. For us, we only have a minus 6 here that we need to do. And we have x squared by itself, and we have a negative 14 with a negative 6. That gives us negative 20. Now this one is asking us to take the square root, so we are going to take the square root. Immediately when you take the square root, the plus or minus appears. So we have x is equal to plus or minus, super duper important, you have that plus or minus, times the square root of negative 20. Now again, if you leave your answer like this, it will be marked wrong. This is incomplete. Everything you've done here was a chapter 4A. This part right here, starting this moment, is chapter 4B. Right? We're testing you on not necessarily solve by taking the square root. We're testing you on your imaginary answers. Yes, ma'am. Correct. So if you take the square root of a negative number, that was in 4A. Now in 4B, we've learned how to deal with the negative square root. So we're going to separate this out into negative 1 times negative 20. But instead of writing negative 20, I'm going to write the factors of 20. What two numbers multiply to 20 when one of them is a perfect square? Any guesses, beautiful people? Beautiful. So now we're going to simplify. We have plus or minus. The square root of negative 1 is what? Thank you. Square root of 4? 2, thank you. Square root of 5? Square root of 5, right? That one doesn't simplify. 5 is prime. And so if you write I2, that sounds like we're going on a highway. We're not. We're in math. So we're going to rewrite that in the correct format as 2I, square root of 5. And this would be our answers. All right, skipping number 8, moving on to number 9. Number 8 is going to be very similar to question number 7. Number 9 is asking us solve each equation with the quadratic formula. The quadratic formula will not be provided, so make sure that you have that memorized. So negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to set it equal to x. Sometimes they give you a different letter to solve for. On question number 9, I'm looking at x, so for us it'll stay x. All right, step number 1, we're going to make sure this is in standard form. It must be in standard form before you do any ABCs. For it to be in standard form, we're going to put everything onto one side. So I'm going to add 1. Nothing for us to combine here, so we're just rewriting it as a trinomial equaling 0. Now we can assign our letters of ABCs to our numbers. We have 5 as A, B is positive 2, C is a positive 1. For our quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, I'm going to erase that a so I have space to write something in it. So b was a positive 2, a was a positive 5, and c was 1. Whenever you're using the quadratic formula to solve, you're going to first identify the discriminant. The discriminant tells you how many real solutions you have. You can have 2 reals, you can have 1 real, or you can have no real solutions. If you have a negative in the radical, that means no real solutions. That doesn't mean you don't have an answer. That means the answer is imaginary. So do not stop if you have a negative discriminant. That just means you're going to have I in your answer. So let's go ahead and type this into our calculators. We have 2 squared minus 4a, which is 5, c, which is 1. Pressing enter, we get a negative 16. Not the worst thing, it is negative, so that means we have no real solutions. That means our answer is going to be imaginary. But I'm also happy that it's 16 because we can deal with 16. Start out by simplifying the numerator by separating out that negative. Now here, instead of writing what times what is 16, I know that the square root of 16 is 4, so I'm just going to keep it as square root of 16 just for one more step. And now we're going to simplify it completely. We have negative 2 plus or minus. We know that the square root of negative 1 is I, and we know that the square root of 16 is 4, so we have 4i. Still divided by 10. Now, before we do anything with that plus or minus, it is an imaginary answer, so we will not be able to combine 2 and 4. So instead of combining 2 and 4, which we cannot do, we do need to simplify. To simplify, you're going to rewrite this as 2 fractions, both having a denominator of 10. If you do this and you cannot simplify both fractions, then this would be your answer. For us, I'm looking at 2 and 10, 4 and 10. Therefore, it, yes, can be simplified, so our answer is going to be simplified. 2 goes into 2 once, 2 goes into 10 5 times, 2 goes into 4 twice, 2 goes into 10 5 times. So you have negative 1 plus or minus 2i, both over 5. You can give me this answer. This is fine. Or because they have both the same denominator, you can write it as one large fraction. And that's our x equals. Yes, ma'am. Yeah, that's fine. Does anyone still need more time on this? Going once, going twice? Okay. All right, skipping number 10, which is very similar. We're going to move on to question number 11, and this one's asking us to solve by completing the square. Just grab a ruler, it's fine. Oops, it's not an example. It is question number 11. So we're going to solve by completing the square. The question is 5x squared plus 10x minus 25 is equal to negative 5. All right, step number 1, you're going to move over the constant to the other side. So we have adding 25 both sides. We have 5x squared plus 10x, and we have a positive 20. If you don't want to write that plus, that's fine. I didn't have to write that plus. Step number 2, we want to divide all terms by the leading coefficient. So we have x squared plus 2x is equal to 4. Step number 3 is our actual completing the square process, which is taking that b value, dividing it by 2, and that is our perfect square. But what that value squared is, that's the c value, and that's the value that we're adding to both sides. So here where we have the x plus 1 squared, that's equal to the addition of 4 plus 1 from the right side. We have x plus 1 squared is equal to positive 5. We're going to take the square root both sides. Make sure you place that plus or minus. X plus 1 is equal to plus or minus the square root of 5. Notice that 5 is not negative. So this is a real answer. It's not in the imaginary world. Might not be pretty because it's a square root of 5, but it's not with I. So we're going to do one last step, and that is subtract 1. Subtract 1, and we're going to write that 1 on the outside of the radical because 5 is inside a house, 1 is not. So we cannot combine them. And this is our answers. These are our answers. Okay, does anyone still need more time? All right, let's go and move on. I'm going to jump down to question number 15 for factoring. We're so used to factoring with patterns, with trinomials, rainbow method, guess and check, that when we get something like this, we stumble. Step number 1 with factoring is your GCF. And a GCF can be a letter. It can also be a number. So we can pull out a 4 from 4 and a 4 from K, but we can also pull out a K from K squared and a K from K. So notice that our GCF is not just 4, it's actually 4K. Step number 2 is, what do we see? After removing a GCF, we want to ask ourselves, what do we see? What are our leftovers? 4 divided by 4 is 1. K squared divided by K, we subtract 2 and 1, so we have K left over. Minus 8 divided by 4 is 2. 1K divided by 1K, that's nothing, that's just 1, so we just see K minus 2. So if there is nothing else for us to factor, it is linear and we have an exponent of 1, you're done. There's nothing else for you to do. You're going to write out your answer as your GCF times your leftovers. Set it equal to whatever it equals. In this case, we have 0, and this is your factoring. These are your factors. Now, if it is asking you to solve by factoring, then this right here is not your answer. This is just your factors. To solve by factoring, you're going to set each factor equal to 0 and solve. We have 4K is equal to 0. K minus 2 is equal to 0. And now we're just solving for the K values. I'm going to divide by 4. I get a K is equal to 0. I'm going to add 2. I get a K is equal to a positive 2. So with factoring, you want to factor first. Then if it's asking you to solve by factoring, then you want to continue from your factors. Anyone still need time? Okay. Speaking of factors, we did learn one more method of factoring, which is factoring by grouping. It's question number 17. We get 18n cubed minus 12n squared plus 12n minus 8. This one is not asking us to solve, so there's not even an equal sign. We're just wanting our bubbles. We want our factors. Step number 1 is GCF. I have an 18, a 12, and an 8. I'm thinking maybe 4 can go into all of these. Because I know 8 and 18, they don't get along. Yeah, I think it's 4. And then we have n cubed, n squared, n, and no n. Therefore, n is not part of our GCF. If we did have an n at the end, then yes, it would be, but we don't. So let's go ahead and divide by 4 for our GCF. We get 6n cubed That's not 6. That's weird. That's weird. So 4 is not our GCF. What's our GCF? 2? Okay, thank you for that. That was silly. Let's do 2 instead. 9, thank you for that. N cubed minus 6n squared plus 6n minus 4. After you get your GCF, you're going to split up the 4 terms into 2 groups. You're going to group the first 2 together. You're going to group the second 2 together, adding an addition symbol in between. You're going to pull out a GCF from the first 2. You're going to pull out a GCF from the second 2. 9 and 6 have a 3 in common. Good. N cubed and n squared. Which one's smaller? Which one's smaller, n squared or n cubed? N squared. Yeah. So we have a GCF of 3n squared. Now we write out our leftovers. 9 divided by 3 is 3. 3 minus 2 is 1. 6 divided by 3 is 2. 2 minus 2 is 0. Now we're doing exactly the same thing for the second grouping. I have a 6 and a 4. We're going to divide by 2. N and no n, so the only GCF we have is 2. We write out our leftovers of 3n minus 2. The leftovers, beautiful people, they must match. If they don't match, either you've done something wrong or it is not factorable. There can be situations where the inside does not match, and they must. Okay, writing out our answer. We want the original GCF. And I'm going to highlight that since we have so many GCFs. I want to make sure you know which one I'm talking about. And that's going to be this purple one here. Our original GCF was 2. Then we want to write out our 2 GCFs that we removed from our groups. We had a 3n squared and we had a positive 2 that we removed. After that, we're going to write out our leftovers. And we're going to write them only once. Even though we kind of see 2 of them, we're going to write them only once. And we have 3n minus 2. For our leftovers, we write them 1 time. Put a box around this. Here are our answers. Any beautiful people need more time? Anyone need more time? Going once, going twice? Okay. We got 2 more examples that we're going to do and then we're going to practice. We have question number 19, which is solve linear quadratic systems, excuse me. By graphing. And then the next one will be solve algebraically by substitution. We have y is equal to negative 2x plus 3. Y is equal to x squared minus 4x plus 3. Once again, I'm going to ask you to create a little T-chart. We're going to have a line. and we're going to have a parabola. The equation without an exponent and the exponent of 1 is your line. The equation with the exponent of 2 is your parabola. For your line, you're going to have a slope and a y-intercept. Our slope here is negative 2 over 1, which means we're going to go up and to the left. The y-intercept is 0, 3. On the parabola side, we have our standard form parabola, so we're going to need our axis of symmetry. We're going to need our y value for our minimum maximum value. Then we're going to need our vertex. So it takes a little bit more on the parabola side. So let's start out with our axis of symmetry of negative b over 2a. Here's our a, here's our b, here's our c. So negative b over 2a. b is a negative 4. A is 1. If you want to do this using a calculator, that's fine. You just need double parentheses in the denominator. Or just do this by hand, which I recommend. So we got 4 divided by 2, which is 2 for our axis of symmetry. Next up is our y value for our minimum maximum. We're going to take the original equation, and we're going to plug in our x value of 2. So we have 2 squared minus 4 times 2 plus 3. We get negative 1. So that means we have a vertex of 2, negative 1. We have a y-intercept of 0, c, and our c value is the value here in our equation. So in this case, it's just 3. Now for the remainder of the points, we will need as many points as we can get. We're going to use just the regular plug and chug method, t-chart. Here's your x, here's your y. I'm going to start off by our vertex, 2 and negative 1. Then you can choose to either go up or down. If you want to go 1, 0, negative 1, do that. If you want to go 3, 4, 5, do that. I'm going to choose to go up. Is that enough points? Maybe. I don't know. So I'm going to type that in. I already have the equation written, so I'm just going to replace it with my numbers. So I have 4 now. Then we have 5. Then we have 6. Oops, 6. Then we have 7. So 24 seems a little bit large. I don't think we're going to be graphing up to 24. You never know. 35 definitely, probably, maybe won't be something that we're going to be graphing. So right now, I am going to ask you to go ahead and go towards the back of the room. You're going to pick up a ruler. Graphing this is super duper important that you use a ruler if the little graph is not given to you. So pick up a ruler for your neighbor, so that way we can graph this to the best of our ability, because it really does matter that you are exact here. All right, when we're graphing, we want to graph the line first. Some of you, I'm noticing, are making a hiccup in that you're plotting all of your points, your dots, and then you get lost. You're going to get lost. If you're going to have two different things that you're putting dots for, but you don't actually connect anything, it's going to get confusing. So make sure you start with your line, graph the line, connect the points, and then move on to your parabola. So we have a 0, 3, 1, 2, 3 as our y-intercept for our line. Then we have a slope that we're going to go down and over 1 to the left. Oops, sorry. We're going to go up. I said down for some reason. We're going to go up and to the left. Up 2 over 1. Up 2 over 1. And I'm kind of using the ruler to guide me on my little jumps. Up 2 over 1. Up 2 over 1. Up 2 over 1. Now once you've gone one direction, go back and continue that pattern on the opposite direction. So now I'm doing down 2 and over 1. Down 2 over 1. Down 2. Here's 1, 2 over 1. About something like this. You can see mine are a little bit, still a tad bit off. That's okay. So like this top point is a little off, so I'm going to move it, make sure it's on the line. Like that. I'm going to go back and highlight the line. On the test, I do recommend you bring some highlighters. They will not be provided, but if you want to have your line and your parabola stand out, you may want to use some colors, so that way you can see the intersection a little bit easier. For your parabola, we have a vertex of 2 and -1. Here's 1, 2, -1, and immediately we have an intersection, so I'm going to circle it. Taking my ruler, we're going to identify the axis of symmetry at +2. And so on the test, I should see a dotted line for your axis of symmetry. That's going to be where your points are reflected over. Now we have a 3, 0, 1, 2, 3, 0. Reflect that over. 1 jump, 1 jump. We'll have a 4, 3, 1, 2, 3, 4. 1, 2, 3. 2 jumps, 2 jumps. I have a secondary intersection. I'm going to circle that. Now we have 5, 8. Now, after you get your 2 points of intersection, you can graph 1 more point, maybe 2 more points because of the reflection, but you don't have to graph everything because you already have your answers. So don't spend too much time graphing after the fact. Just get your answers and then move on. So I'm going to graph 2 more points and then call it good. So we have 5 and 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 3 jumps. 1, 2, 3. 1, 2, 3. 3 jumps. Curve and connect. So we have 2 points of intersection. And those are going to be our answers. So the first answer we have is 0, 3. Second answer we have is 2 and -1. Yes, ma'am. Right here? This one, the U? So that's the parabola. That's the points that we graphed using this. We have one more example that we need to do. I'm going to go ahead and continue. And this is going to be our last one for the type of questions you're going to see on the test. So the last one is going to be solve the system using substitution. So keyword here is substitution, meaning you're going to be replacing something with something else. So we got y equals negative x squared plus 2x plus 7. Y is equal to negative 2x plus 2. Step number 1, make sure both of them are equal to y. Once both of them are equal to y, you can set them equal to each other. Yes, ma'am. Move. Yep. You're welcome. So we're going to set them equal to each other. Move them over all to one side. So it doesn't matter which side. I'm going to choose to move everything over to the right-hand side. And the important thing is you have to have it equal to 0. Now, if you are choosing to factor, I highly recommend you factor, just because it's going to be easier. If you're choosing not to factor, if you're choosing to use the quadratic formula, it's just going to take your extra time, but it still will work perfectly. If you are factoring, make sure that you remove the GCF first. In this case, GCF is negative 1, so we're going to divide everything by negative 1. So that means what we see is x squared, minus, not plus, because we were removing a negative 1. And then negative 5. I moved the 0 to the other side just because I forgot to write it first, but it doesn't matter if the 0's in the beginning or at the end. So we have a trinomial with a leading coefficient of 1. Help me out, beautiful people. Two numbers that multiply to a negative 5 but add up to a negative 4. What are our guesses? Do you have it, Lex? No. So we want two numbers that multiply to a negative 5. Same two numbers add up to a negative 4. Negative 5 and positive 1. Thank you. We're going to solve and get x is equal to 5. We're going to solve and get x is equal to negative 1. Remember, beautiful people, this right here is not the answer. Don't pack up yet. We got 30 seconds and we're done with this question. 30 seconds and we're done with this question. Take the smaller equation, the linear equation. Write it out twice. Plug in your original x values, negative 1 and 5 that you just solved for. Solve them. We get negative 10 plus 2. Ooh, I know. Let's finish. I know, beautiful people. I know. I never do this. We got 10 seconds and we're done. We got negative 8. Here we got y equals 2 plus 2. Y is equal to 4. So that means, you ready for our answers? 5, comma, negative 8, and negative 1, comma, 4. Pack up. Goodbye. I'll see you tomorrow.